Okay, the handout that you guys just picked up, I have some more practice problems for us to try. So if you guys can attempt these parts on your own, I will go through these with you. The key is attached, but I just want to see how much you can do. I do want to point out something here. Look at part D here. It's a limit problem. What would be the first thing that you would do with limits?
Direct substitution.
Plugged in, right? Direct substitution. Now, let's say this gave you 0/0.
It'll be tough.
It'll be tossed. All right, so if limit is going to show up on the AP exam, a lot of times for at least for BC students, it's probably going to be something in this L'Hopital's realm. So I want to make sure that we're good with that. We'll do another of these problems on Monday before your quiz, but want to make sure that we can recognize of application of L'Hopital's. Okay, but go ahead and start with number 3.
To do arc 10 of 1, do I just look at from 0 to pi? So that's okay.
You can get it right.
You get 2 + 2 = 5.
Right now. Like, I think I'm just gonna. Oh, you said for English. What do you have to put down? That's it.
That would be.
You're on some names now, but that's what we're for.
Yeah,
Brad, you heard that case and go to bed like.
it's a the question.
What you do next to?
No.
You told me that. I know, like, it's like long.
1.5 times. It just says, I read the question. Like 1.5.
Okay.
Which is
I
not.
went to 2.2. I quit. That's good for him. So, these you can stop. Yes, that's one, that's one.
No, that's 1/2 to 1.
That's one. What they good?
Oh, you think about.
Going, like,
Yeah.
can you like finish that so I can finish it?
It's 6.4.
It's like really slow. It's not really fast. I was like,
Oh, that's what I did.
so was it good?
It's 2.
You think it was good?
You didn't ask why it's not easy. Not always. That's the better one. I'm reporting a derivative of tradition and opti.
Stays for like a year. Yeah.
Art kind of.
Not that strong.
25 home reasons. Yeah.
And this is like, maybe look at the know this stuff. That's
You close the next outside where that. Equal one.
That's cheating. That's cheating.
Yes, together, get one.
Oh, wait,
And
you
you
have
have
it.
Yeah, and so you have, so you should find here did this.
That's okay.
Wait, why is it locked in?
Like, I mean, this is probably the same one. Well, that's one deal.
I'm just not like, I need some fun to do.
Okay, let me go over number one, or the first page here. The part A says the depth integral from -6 to 5 is equal to 7. So this includes a region that we don't see because the graph only shows us from -2 to 5. So -6 to 5, we know this included shown region plus this hidden region is going to add up to be 7. It says find the value of that hidden region that we don't see from -6 to -2, but we can find the value or the displacement for the region or the area between -6 and -2, the region that's shown. So all these are geometric shapes, or if not, it's going to be something that can be found using geometric shapes. And so we have this triangle. Remember, we're only looking at the graph, looking at the region between the graph and the x-axis. So you got this triangle above the x-axis, triangle below the x-axis, triangle above. You have a square and a triangle, and then you have this region here. This is by itself is not a geometric shape, but this is a combination of geometric shapes. We can think of it as a square subtracting a quarter circle, and what's left is this curved triangular looking region here, right? So the triangle and square are easy. So here the square is 3 squared minus this quarter circle. This quarter circle has a radius of 3. So 1/4 pi r squared. So the square minus the quarter circle will give us this region here, which is 9/9/4 pi. So we know the full region equals 7. The hidden region is the unknown that we're trying to look for. But we know the full region is the hidden plus the shown. And the shown region we can add up using geometric shapes. And then finally, we can find that hidden region by doing 7 minus this 11 minus 9 pi over 4. Part B, you can simply rely on first theorem, but just be careful here because these are actually 2 separate processes. The first term, you can go through first theorem, but the second term, you got to make sure that it's not just a +4 at the end, it's plus the integral of 4. So we got to go through power rule here. So first theorem can be applied for 2f prime, but then that 4 is going to become 4x. We got to go through power rule for that process.
I don't have to split the integral, right?
You don't have to. I just wanted to split it up so that you can clearly see I'm doing 2 different things there. But yeah, you don't have to split it. Okay. Part C is understanding that you're looking at a derivative graph. From a derivative graph, you can pick off relative max, relative min. And then if you want to find absolute max, think about applying extreme value theorem. So we want to find the y value at the endpoints as well as the y value at the critical points. So use the rule for us to find each of the order pairs, and then whatever the highest order pair that we can find, the highest y value, that's our absolute max. And part D is so normally part D would be asking for you to apply L'Hopital's rule, because usually that's what happens. In this case, though, when we evaluate the limit, it just gives us a real number so we can stop. Right? But typically, the way that limit problems are going to work is if it doesn't give you a real number, chances are it'll give you 0 over 0, and from there you got to find the derivative and then reevaluate using L'Hopital's rule. But Part D looks like it just works out nicely to be a real number. Okay, let me see you guys finish off this problem, and let me see if you guys have any questions before we move on to the next one.
We have to worry about L'Hopital's rule for like infinities.
It's possible. I mean, L'Hopital's rule, indefinite, indeterminate form is also infinity over infinity, but most problems that I've seen have been 0 over 0. But technically, infinity over infinity can also allow you to apply L'Hopital's. Okay, page 32, number 6 should feel familiar, similar to what you saw yesterday.
Well, the rest of it's just. Yeah, it's same as the other ones. There's really about 40 different. We have 14 safety. Important.
So I'll go over the second page in a moment, but if you're done with these two problems, go ahead and do page 19 and 20, get homework out of the way, so don't do anything over the weekend, so. But on Monday, I'll be checking these 4 pages for homework. But we go the first 2, go to page 19, that's 20. But I'll go over this problem. That's it.
How many questions would be on the list?
It'll just be one problem front and back. So very similar to what we was talking about. Yeah.
Fish, right?
Guys, on Monday, we're gonna do an extended version of what you're gonna see on Tuesday's quiz. So Monday's review is going to will be longer than your quiz, but it'll be very similar. So, not gonna be as long as this review, this morning review, or it says morning review, it won't be as long as that, but it has all the elements that you could possibly see on the quiz. So we'll run through that Monday. But it's just a variation of what we saw yesterday, and also very similar to page 32 as well.
It's gonna stop. Area quality. Maybe it's really. Yeah, I think it's.
Okay, so page 32, or second page of your handout. Part A, find the slope of the line tangent. So that means from part A, just have to find the derivative, very similar to what we saw yesterday. Cosine's derivative, and B to the sine x derivative, we got the derivative chain rule. Then rely on inner circle values to get it down to our slope value. Part B, K of x equals H of f of x. Hopefully we see the need for chain rule. Apply chain rule and then evaluate the slope. Part C, there's a need for a product rule and a little bit of chain rule, right? G of negative 2x becomes G prime of negative 2x times negative 2. So, but bigger rule that we need to apply is product rules. After we apply product rule, replace every x with 2, and then try to get it down to a numeric answer. Part B, is there a number C such that G prime is equal to negative 4? Almost trying to see if you can recognize by the wording that, we're trying to lead you towards mean value theorem, right? Can we guarantee a slope of -4? So if I can find the slope between the endpoints, and if that matches -4, then we know that there must be a place on the curve that's also going to share that slope of -4.
One place where I don't know the, it's like H2, like I can't.
Yeah,
System is.
Well, the thing is, it is still predictable. It's going down by -1/3. So every it's going to be -1/3, -2/3. So it's predictable enough where we can find it.
For the second one, I can't tell whether to apply MVT or IVT here. Because they also give it a kind of like stable. They both give different answers.
Yeah, so you're right. It could be either mean value theorem or IBT, but IBT looks like IBT, I can't quite guarantee it because I need a value lower than -5. Sorry, lower than -4 if I want to guarantee that's lower than -4, right? It may never hit -4. So that's like, I think he's not gonna lose, but I think it's gonna approach.
I just looked at it.
Like the slope of g of x can produce -4, then therefore g of x is -4.
So, don't worry, then I can fully say.
Right, right. But this is an exam problem. Typically, if they word it that way, they're trying to get you to use either mean value or IBT.
It's even they get one thing, so it's like easy to like consult.
Right, right. But yeah, sometimes it may be software you have to kind of prove like, yeah, is it IBT or something about it. It's typically one of those two. Okay.
It's a great. It is good. No, it's not. It's just great. Like you've read the great things do this that I hope you get. TV shows like using me for like let my old person. Oh, the first tape I guess is pretty good.
Okay, if you're done with these problems, I want you to go ahead and start page 19 and 20, which will be part of your homework. Back in, that will check out Monday.
Are the quizzes coming up with or without calculator?
I want to see your work, like if you do not have a calculator, but I will give you a calculator to use.
Okay, check that. Big one checking.
Yeah, check it.
Then you feel happy with that. And somebody else. Okay, see. Oh, you need your son. It just looks weird. It's not like we want to do this. It's I think I say
No, just thinking you're not your character is right here. Something said like, you said this.
so. What do you mean? I'll let you say it.